Okay, we are back. Welcome back for video number 2 in this series. The first one we talked about Catalyst EVPN and the overview. This time I'd like to do a little bit more of a packet walk. Now, I did say in the last video I would do a section for each of these, but you know it's going to take a lot of time to do that. So what we will do instead is we will just do an end-to-end packet walk, and we'll try and capture as many of these use cases as we go, and just trying to get you all familiar with the fabric. So quick refresh or introduction, if you like, how we have in our fabric topology. We've got two borders. This is a border spine, a border leaf. Remember, the leaf connects to endpoints, which we have a blue trunk link down here to a switch. A switch is running a protocol called REP, Resilient Ethernet Protocol, because we don't support layer 2 dual homing with EVPN. So we're using this as a kind of a active standby link setup situation. Then we have a leaf switch down here. The leaf is there. The leaf means it connects to endpoints, and it's got a client connected downstream on this access port. This is a border leaf because the border functionality connects to external networks. I have a BGP peering with the firewall down here, and then beyond the firewall we have some other networks. We've got this client down here. So our fabric consists of these three nodes. Border, because they have the BGP peering. He's a leaf. If this link was to flip over actually, and this was to become active, he would become a leaf because he'll have the client tenant connected downstream on his port. So for today, we're just going to have a look at what's the flow of traffic for client 1 to ping client 2. This is VLAN 666 and VLAN 3. I think that's a typo. If I go to the next slide, let's go into 33. They're both in VLAN 33 from a fabric perspective, but we're going to validate this. So let's quickly take a look at the configuration of the fabric itself and what that looks like. So we have the L2 VPN configuration. Here, the replication type static. The other option here would be ingress replication, which is used for replicating packets throughout the fabric. We defined our EVPN instance ID for 40,033 with our root target import export variables. And then under the VLAN configuration, we've mapped that instance to that particular VNI. I've used the same number here to map this instance. So these are tied together to the VNI number. And then the VNI is then associated to the VLAN, the core VLAN. So this is VLAN 999. Here's our core VLAN. So he's used for transporting the packets in the backbone of the network. And then interface VLAN 33, so this is our SVI, our switch virtual interface for that particular VLAN. So we can see sort of description, but you can see it's got a MAC address statement. Now all of the EVPN fabrics have the same IP address and the same MAC address. This is what's known as Anycast gateway. In particular, it's a distributed Anycast gateway, which means that it's prevalent, it's deployed on all of the EVPN leaves, as opposed to another type of gateway. You can have a centralized Anycast gateway where you have 2 or more gateways configured within the fabric where all traffic is pulled towards to provide gateway services. You can have distributed Anycast gateway, as we've just talked about here, which is the same IP and MAC address everywhere on all leaves. You could have a unicast gateway, which is more traditional, where each of the VLANs has a unique IP address and MAC. Or you could have no gateway at all. You have a layer 2 extension. So if you don't configure the gateways, you can just provide L2 overlay services only. So here is an example of both L2 and L3 VPN type services. You can ignore the DHCP things, and then of course we have PIM enabled because we will be using multicast. Now, what else? So on the VLAN 999, this is the core SVI. He is mapped to the tenant VRF. In this case, it's a VRF overlay. You can, of course, with EVPN have multi-tenancy, so you can have multiple VRFs configured. And he's on number to loopback 4. Loopback 4 is in the global routing table actually, and it's just the NVE IP IP. That's what he's assigned for. And then we create the NVE interface itself, number 32. And here we have mapped two things. We've mapped core DNI 40999 in the VRF overlay. So you can see this number here correlates to the VLAN configuration. It's associated with 40999. So 999 maps to 999, maps to VLAN 999, into interface VLAN 999. My phone is always distracting me. And then we have 40333 or 33, which is mapped to the VLAN configuration 33, which is then mapped to the instance ID 40,033. Here we define a multicast group. So we're saying for any BUM traffic, broadcast, unicast, or client tenant multicast traffic, what we'll do with that is we will encapsulate that in VX-LAN with a destination IP address of this multicast IP in the underlay. So that's in the underlay. Okay, that's important to note. So moving on, and what else do we have? So we configured BGP. I've used peer groups, and essentially each of the neighbor statements are in there for each of the peers. And I've activated the MVPN address families for each of the neighbors. That's for multicast. And the layer 2 EVPN address families. And also for the VRF overlay itself, I'm redistributing my SVIs in to provide reachability to maybe external services or within the fabric. Other configuration we have, is there any more? I think there's one more. I'm going to move my ugly mug over there, get away you. So we have a loopback 0. This is our global IP address, because under the hood here for BGP reachability, we're actually running OSPF. You can see OSPF process ID with area 0. We mentioned before, if we look back over here, this member VNI is mapped to this multicast group in the underlay. So what do we need in the underlay? That's it, you've got it. We need an RP address, and we need to enable PIM. Which we have. You can see we've got PIM sparse mode on the loopbacks and also on all the layer 3 point-to-point links, which is not shown. And and it's an anycast IP, the RP address 1234. If we look down here to loopback 1, we can see that it's an anycast RP. And if we have anycast, then we're going to need to have MSDP to share the sources amongst the rendezvous points. If you want to know about anycast, I did just do a video about anycast because just to save me not having to talk lots in these videos, even though I do. I can't help myself. And then we have loopback 3. Loopback 3 is the overlay rendezvous point for the overlay VRF itself. We can see we have the IP address, which is also defined in the PIM statements above. With MSDP again between a unique IP. So it looks like a lot of configuration. It is. There's some others config that's not actually there. There's the VRF configuration for the VRF overlay, but essentially it's kind of a high-level introduction to what that configuration would look like. So if I was to stand up another VLAN, then I would need to create another instance ID, correlate that, map that to the VLAN itself, create the SVIs, then add it as a member under the NVE interface, and that is about it. So that is what we need if we were to. Where's my pen? Do I get a pen today? I'm clicking on the wrong one. Yeah. So this, and this. If we were to build, once our fabric's built, if you were to provide a new overlay service, this is the configuration that you would need to deploy for that new service. The rest of it's for the underlying fabric itself. I may have missed one, but all right. Let me get rid of my pen. No pen. Just go my pen. All right. Okay. On with the show. I'm going to move myself back over there. Oh, you like my little pony in the corner? It's my daughter's pony, by the way. So what are we going to do? Okay, this is my last slide. We're going to work from, we're going to do a ping from client 1 to client 2. I'm going to mute my phone. Alright, I already have my consoles up and running, ready for us to go, folks. So let's start, shall we? How do we do? So first things first, I'm putting some commands here to save my memory, so and then you can have them for your reference. But just to give you an understanding, if I look at the show interface Ethernet 1.45, I should switch to the run really, so nice and easy. We can see that we have a routed port with an IP address assigned, and it's currently not shut down. And what are we trying to do? We're trying to get to client 2 over here on connected to this downstream access switch. So it's a tenant switch in the fabric. So the first things, if we do show interface Ethernet 1.45 status, which we've already validated this in the running configuration. What I'm looking for is what kind of port is this we're working with here. So we can see we have a routed port, not a trunk port, not an access port. What is our route currently to 10.33.0.2? Well, that is reachable via ourselves out of this particular port here. Okay, and who am I adjacent with on that particular port? Forwarding. I'm on. This is a Nexus, by the way. It's not the my most comfortable platform to work with. I'm more of an IOS guy. And we can see here it's we are adjacent with this next hop, and this is the MAC address of the next hop. Do we have though an ARP entry for the .2 address? No, we don't. We only have ARP for our default gateway, which is this IP here, which we can check out on the leaf switch. I do show run interface VLAN 33. We can see here that this is the MAC address we've hard coded, and just to prove to you that I'm not telling you porcupines, we can see that it's the same on all of the other fabric nodes. Oh no. There we are. I copy and paste, auto highlight and paste. I have burned many a boxes doing that accidental right click and pasting the wrong configuration on than I care to admit or care to remember. So what happens now? We need to just do a ping, but to do the ping we first need to resolve ARP. How does ARP work? Well, it depends. If this client is already online and he is sent some sort of traffic, DHCP, a GARP or any kind of packet, so that the leaf here has learned his IP and MAC, then that information will be available to us in BGP. But I tell you for a fact that hasn't happened because I've shut down this port. Why? Because I want to show you how this traffic flow works with like a silent type host and what happens with our ARP requests. And it's no secret, it's flooded to everybody, and it's flooded using multicast, which is why I have these debugs I want to run. So on the leaf switch here, I'm going to turn on debugging for multicast packets for this particular group. Why that group? I tell you why. If we look in the NVE interface, we'll see that the VNI 40,033, which is the one that's tied to VLAN 33, is mapped to this multicast group in the underlay. Show IPM root. See, in the underlay. Happy with that? So that is the right group, isn't it? 201. Yeah. All right. So we're debugging that and debugging ARP, and also I'm going to debug ARP on the end switch. Debug ARP. That's the noise to say that I don't know what I'm doing. I'm going to push mute. So let's just do a simple ping and see what's going on here. So we want to ping port 10.33.0.2 away, hi-ho silver away, and we've got the leaf switches fired up to life. He's received an ARP request from .1 with .1's MAC, going to destination 2, and then we see a packet being sent from 11111, which is our VTEP interface, our virtual tunnel endpoint, so it's for VX-LAN, and it's destined towards this particular destination. So it's a VX-LAN encapsulated packet with destination IP of class D for multicast. And then also, if we look on the remote end, we've received a couple of ARP requests as well from .1 for this destination. Now, let's just have a look again at that IPM route. We'll see that now we've got outgoing interface. Our incoming interface is our loopback 4, which is tied to our NVE interface, and then an outgoing interface towards the other leaves that have this particular group and VNI configured, in which case all of our leaves. So that is flooded. So everybody's getting a copy. Border switch over here, the border leaf over here, they're getting a copy. They will decapsulate that. They will then look inside the packet and they'll go, oh, okay, what's the VNI? And what ports do I have associated with that VNI? If I have ports, then I'll flood it out of those ports, with spanning tree now. If not, then I won't. I'll drop. And I can tell you it's just this guy that's got ports in there. I haven't got enough boxes to connect stuff up here to do all that. All right, and then there's another capture I wanted to run. Can I do that right now? No, let's do some more validation. So on the leaf switch, I want you to see, so the packet's arriving. We do a show IP Ceph, the VRF overlay, for the destination 10.33.0.2 detail, and we can see that this is saying it's attached to VLAN 33. Rightly so, because VLAN 33 belongs to that same subnet. But if we do a similar command, check for 1, we can see it's also attached to VLAN 33, but we'll check this out from a remote switch. I mean, you need to know what normal looks like to know what abnormal looks like. So from border leaf 2 up here, we can see this is actually saying it's reachable via the next hop of 1111, which is VLAN 999, which is the core SVI. So we route that across VLAN 999 from border leaf 2 to 1111, decapsulates the VXLAN packet, and then it's sent onwards towards the ultimate destination. We don't see this on leaf switch 1 for 2222. We're saying that's just attached locally to our VLAN 33. So it's bridged. So we look at the bridge domain, show bridge domain for 33. We can see what port's part of our bridge domain. This is kind of like show spanning tree. But the spanning tree won't show us, it will show us the physical ports, it won't show us the VNI port here that we're interested in. So the VNI, so I show NVE for VNI 4023. We can see that this VNI is mapped to this multicast group because we've already validated this. We can see that bomb traffic, broadcast unknown unicast, ARP, multicast is then flooded on this particular group. Okay. What else is interesting to know at this point for validation? How else could we validate it? We can check. So remember that this border leaf over here knows how to get back to client 1, because client 1, when he sends his packet in, this leaf switch here, he creates a BGP entry, show BGP, VPN, sorry, I'm so used to typing that, L2 VPN, EVPN, and I'm just going to go and include 10.33.0. Let's have a look. So we can see we've got a root type 2 for 10.33.0.1, which is client 1, and then we can see his MAC address. And there is a really long, lovely command. So we've got EVPN root type 2, and then it's the ether tag is 0, and then I think we type in the hex string, which is this MAC address, and then we have an optional IP address, which we can type in here. It's going to be one, so these BGP commands are just, one day it will be like show BGP, EVPN, L2 VPN, you know, I run out of thoughts, just blah, 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 blah. Oh, sorry, you made a mistake here. So much like a normal BGP, we see it's come from ourselves, so we've locally originated that from 000. It's best. We've got the label. It's the VNI ID. All the other wonderful jazz we have with a BGP. We've got the extended communities, so on and so forth. What we don't see in here is we're not seeing anything to dot 2. If we did, then we would send the packet, the ARP packet, directly to dot 2. And interesting, this is a root type 5 because we are redistributing our connected routes. So I would redistribute SVI. We then create a root type 5 for that particular interface. And if we also have root type 5s for any remote learn, externally learned prefixes. Okay, so what have we done so far? We have done a ping, we've done an ARP request. If we look on this guy again, if I just do the ping, we're sending our ARPs. I don't know what's happened to my camera. What? Let me go back there. Oh, doesn't love me anymore. I changed to the other camera. It's not bad, I guess. The other one's a bit rubbish, but yeah, a bit of a wider angle. We've got a lot of white light. So where were we? Ping. We'll do show IP ARP. Show ARP. Yeah, it's unresolved, right? And we can see those ARP requests. We can see our multicast packets going out, and we can see our ARP requests arriving on the remote switch. Not because that's where the client ends, because we could just do a ping for 25, and I'm going to see those ARP requests arrive there as well, because they're flooded. Flood and learn. Let's now bring up the interface on this guy where the IP lives. Show IP in brief. Just to show you what I've done. There's nothing magical here. Again, I've just created SVI because my port density and my ability to pillage clients for testing for you people is somewhat limited, and my resources are not eternal, and I do this as a best endeavor, so I hope you enjoy. Let me know. Let me know. No shot. Oh, come to life. Thank you. We're debugging ARP, so yeah, we can see we MAC address. Yes. Good. Thank you. Now, some traffic may have been sent. There may have been a GARP or something going from the client up to the border leaf here. Let's just have a quick look on the leaf switch and see again that same command. Oh, look at that. We now have root type 2s for .2, which is the remote end. And we have 2. We do have 2. Why do we have 2? Good question. We've got the one we've received from the leaf itself, from the border leaf. And because we're actually advertising our layer 2 VPN routes into our local ribs, we're redistributing those routes back in ourselves. So we're also generating a root type 2 locally. Let me show you. This, the MAC, and the IP. It's a little bigger for you folks. Essentially what we have is we have the one being advertised to us from the remote border leaf, this gentleman over here, or lady, or other. 4.4.4 is his VTEP IP and his MVE IP as well. As well as the governs, the attributes that come with that root. And then we are importing that as well into our own table. So we're seeing two things. We can see this is the best one. This is a preferred root, which is good. This is what we want. Okay. Well, the ping. Before we do the ping, let's do a monitor capture. Monitor capture for you. If I just show IP up again, we haven't got an adjacency yet. Oh no. So if we do ping, we should get we shouldn't get a multicast flood now. Right, what should happen? So let's turn this on. Let's turn on the leaf. Let's go onto the leaf. Let's turn on that monitor capture. Copy that. Copy. And paste. So what that's doing, it's just capturing anything from 1111, which is ourselves. Well, it's the leaf switch here. This is VTEP going to 4444. Let's jump over here. So the ARP request, the flooded one, that goes via the multicast address. If it's unicast, then it will go via this particular address. So we should be able to see the packet. And it's going out of this interface 112, which is the shortest path to this guy. All costs are equal, all things are equal. But all things being equal, bandwidth derived cost, done. So let's ping again. Let's ping again. Like we did that. So we'll ping 25 just to show you that we can still see there is the multicast happening. So we're debugging the multicast packets, remember? And on the rec guy, we're seeing that appear as well. Now let's ping .2. This is the moment you have all been waiting for. So the drum roll. Ping. No. Yep. Hallelujah. Look at that. Do you see any multicast traffic? No, you do not. Why do you not? Because, let's go monitor. Let's just stop this. Monitor capture EVPN stop. Captured 6 packets. All right. We'll look at those in a second. And we can see received the ARP request, and then they sent the ARP reply. Excellent, excellent, good stuff. And on client 1, if we show IP ARP, there it is. Who knew ARP could be so exciting? Because it is. What a wonder. Right, let's have a look. Let's go on to the leaf. Let's go show monitor capture EVPN buffer. There we go. Let's just go brief, buffer brief. So nice. There are packets. 6 of them, all 6 of them, going from 10.33.0.1, and it's just our ping request. There's our ARP. There is the ARP. There's some cool stuff you can do with this. You can go buffer. We could do a dump, and then dump that into Wireshark, and then we can get a nice PCAP that way. I'm going to do a detailed here. It might be quite noisy, but we can see the frame here. We can see it's Ethernet encapsulation as it goes across. Yeah, it's Ethernet. We're happy with that. What else are we seeing? So Ethernet. Oh, let's stop. Yeah, cancel out of it. Nicely done. So it's Ethernet 2. Then following the Ethernet header, we've got a IP header, source and destination. So it's unicast. So it's sent direct. Excellent. And then it's a UDP destination port 4789. Source port. Remember, this source port is a hash of the inner payload, so we get entropy. Then it's a VX-LAN header. If we look in the VX-LAN header, we should see somewhere the VNI, there it is, for 2033. Then it's another Ethernet header, because we carry the L2 and the L3 information. So this other Ethernet header, this is the source of the client itself, and then we've got ARP, and then there's ARP, and then we're saying, hey, here's my info, here's my info. We don't know who you are, but this is your IP. Please send us the reply. Which is, and then so basically we can see that is unicast, so it's optimal ARP packet delivery. Why does the leaf not respond on behalf of the remote leaf? Did you get the answer? So I don't know if this is the official answer, but if it's anything like software-defined access, the answer will be because what if that client has moved in the interim on which you have done, while you've been doing an ARP request, ARP reply, you will then have older, stale data and incorrect information. By forwarding the ARP request directly to the leaf, point of attachment leaf, so where the remote client is, we ensure that we are getting the correct information, because ultimately that end client is the one who needs to respond to the ARP request. And if we don't, then we can clean up our databases. Cool, that is fun. So there's more, there is more. This is quite a long video. Sorry, not sorry. If we do show IVSEF, BRF overlay for 10.33.0.2, more detail, let's have a look. We can see here that before, do you remember before? It was saying it's out of VLAN 33. Well, now we can see it's out of VLAN 99.1999. We know show BGP EVPN, sorry, it's L2 VPN EVPN. We know its MAC address. If we include 10.33, that'll do. We can see there is his MAC address. But interestingly, we do show MAC address table dynamic, and we look for that MAC. Let's just put the last 3 in. We got a, is it 45? It's 6A45, 6A45. I didn't include. Nothing, and then just to be sure, it's not in there. Where is this information hidden? I hear you asking. Well, actually, it's held in the L2. If I look at the show, the L2 fib, the layer 2 fib, for our bridge domain, what is the number? It's 33. Yep, and then we're going to go address, unicast, and then put it in. It's going to be like that, and the dots. Is it the dot in the right place? There we are. So we can see actually that is adjacent over a VX-LAN tunnel with 4.4.4.4. So we need to send that by VX-LAN to the remote border leaf. So we know the layer 2 information for the inner packet, which actually we won't use that. That would be used by the client itself. So he'll send a ping, he'll construct a layer 2 destination headers, send it to the leaf, and then the leaf will then do a lookup in the fib here. Sorry, not there, not in here, in here, in the L2 fib. And then they'll find out, well, where does that need to get sent? That needs to get sent to 4.4.4.4. Yeah, we can do a show. So 4.4.4 is reachable in the underlay, because it's part of the fabric. It's the fabric detail. We do a show IPsef for 4.4.4.4 detail. We can then see that it's reachable out of this particular interface and that particular next hop. And if we do show an adjacency for this IP on this interface, let's do a detail. Thank you very much. We then know what the layer 2 and the encapsulation is for this particular endpoint. So we have this MAC address and 0800, so we have the encapsulation as well. So we now know the layer 2 and the layer 3 information to send that packet in our VX-LAN tunnel. So good stuff. I'm going to stop here because if I look at my time, that's 36 minutes. I'll probably do a little bit of editing and take about 10 minutes off. And then I will, what have we got to look forward to? Where did we go? Take you back in. So we talked about underlay multicast. We talked about the gateway type in particular. We talked about distributed anycast gateway and ARP. There is more, but I've given you what I feel to be the key points. I'm not going to promise to make another video about this unless somebody asks for it, because I don't know if I'll have the time, because I'm back to project work next week, but I'll endeavour to get something done. Cool, thanks for listening. Wonderful weekend. Oh, and it's Independence Day, I think, so if you happen to be in America, happy Freedom Day.